started. If you guys don't have any more questions for me. Oh, we haven't set a like goal. Okay, last time I think we hit 30K, which is insane. We reached our record. We are usually hit like 20K, but this time we hit 30K. I think we can do 30K again. Okay, so if you guys can get 30K likes, I would really, really appreciate it. Make sure you're sharing the live and commenting and being interactive as possible so that I know if you guys like these lives or not. Where can you find this paper? Ooh, so there's lots of past paper resources. I'm going to share one in the comments. There's one called Pestle. I think it's called like this, if I'm not wrong. But it has lots of past papers that you can use. And if you're talking about the data booklet, you can literally just search up IB Chemistry data booklet. Okay, I'm going to go ahead and get started so I don't waste your guys' time. It says alkanes are commonly occurring organic compounds. The first 4 straight chain alkanes are gases at room temperature. And it shows you the number of carbon atoms and the boiling point on the y-axis. Explain why the boiling point increases from methane to propane. Now, with these type of questions, the first thing you want to look at, because I would say they're pretty simple questions in comparison to getting a calculation question, which is like, whoa, you know? So with these types of question, your main priority is make sure you get all the marks. And how do you do that? Is just by looking at, first of all, how many marks this question is. So before you answer, look at how many marks and know that this one is 2 marks. So make sure you mention 3 to 4 main valid things that the examiner that you have seen in mark schemes before, or that you think the examiner can check off, to always make sure that you're getting the mark. Now, a good tip I have is, of course, do your past papers fully, but review everything in the mark scheme. Even if you got something correct, memorize how the IB has stated it, or just repeat it a couple of times in your head. So in the exam, you know exactly what to write. Okay, someone said London dispersion force is perfect. So the first thing you have to identify is identify the type of bonding. So whenever IB talks to you about boiling point or any physical properties, boiling point, melting point, you're always going to think about those bonds in between compounds. What are these bonds in between compounds called? Are they inter or intramolecular? Inter. Okay, perfect, guys. Exactly. So whenever you see a physical property, always connect it to, I'm going to have to talk about the intermolecular forces. So if they're asking you, why is the bonding of this so high? Try to see if there's hydrogen bonding. Then say the intermolecular forces, identify the intermolecular forces, and then explain them a bit more. In this case, we don't have hydrogen bonding. Someone mentioned above perfectly that we do have London dispersion forces. But always remember, with physical properties, your answer is always going to be in relation to intermolecular forces, okay? So you've already got that down. Boiling point, why does that increase from methane to propane? Name drop, intermolecular forces. What are the intermolecular forces? We have the LDF forces here. And we know the LDF forces increase with what? Why do they increase when you go from methane to propane? And the hint is the number of carbons. They increase with the mass, exactly. Increase with the molar mass. So one point the IB was looking for is that you've correctly identified that this is a London dispersion force. The second point is explaining how it just is stronger with more molar mass, okay? And you can say, I guess in this one it's kind of nice because they don't say explain using the graph. But if they ask you to explain using the graph, be very careful. You would only get that mark with the explanation if you talked about the graph. So you see they give you a lot of space, but they're just looking for 1 mark here and 1 mark here. Okay? This is IB. Okay, next it says explain why the volume occupied by a sample of propane increases sharply when the sample is heated from 200 to 250 Kelvin at constant pressure. So why does the volume occupied of a sample increase when you heat something up? What can you say happens when you heat it up? What happens to our gas? And maybe you can see the boiling point. Because the boiling point means we're going from what? We're going from a liquid to a gas. And so try to identify how many carbons there are in propane. Look at the graph and talk to me what you see in the graph. And make sure you focus on the temperature as well. Thank you guys for 1K likes. We hit 1K. I'm sure we can get to 30K. That was our goal. Use P ever and T pushes. Okay, I like where you're going, Ali, but you have to be careful. It's just talking to you with reference to the data. I know it's a bit hard, but try to think about if they're giving me the boiling point and I'm trying to have propane. Propane has 3 carbons, okay? So if it has 3 carbons, I know the boiling point of propane is in between roughly like 200 to 250. So if I'm going from 200 to 250, I've definitely went beyond its boiling point. So the reason, number one, that you can get a mark to like get this answer, you can say that it evaporates. Therefore, takes up more volume. That's one of the marks. Now, what is a second mark you can say? You can say because it's a gas. What does it mean that something is evaporating? You just say it's a gas. Therefore, it's taking up more space than a liquid would. So a good thing I always like to tell my students when they're answering questions is how they always ask me, how do I ensure I get full marks? Look at the number of marks they're giving you. In this one, it was 2. Then keep asking yourself why. Ask yourself why questions and ask yourself as many why questions. Why is this the case? Why is this the case? Until you think you've met the requirements. So if the question is worth 2 marks, make sure you've asked yourself why 4 times. So if something evaporates, it takes up more volume. Why does it take up more volume? Well, because gases occupy a larger volume than liquids. You can ask yourself why. You keep asking yourself why, and in this way, you can try to get as many marks as you can. I found that really, really helpful. Is this HL or SL? This is HL, but if you're SL, you should be able to solve this as well. Is that bio? No, it's chemistry. So I see a lot of you guys went into the kinetic energy. You talked about the difficulty like entropy. Okay, you wouldn't really have gotten marks for that. You were saying correct information, but in this case, they're just trying to take such a simple question and complicate it. Remember, it doesn't have to be so complicated. In this case, it's not. But you could have mentioned the entropy. You could have mentioned this. You just wouldn't have gotten marks in it for it. But that's okay because IB doesn't remove marks. Okay, let's move on to the third question. These are paper 1B type questions. Ooh, interesting question. They can show up on your paper 2 as well. So this is an old paper 2, but they are. Let me see here. I think this one would be a paper 1B question, but the next ones are going to be more database paper 2. All right. It says calculate the volume in decimeter cubed occupied by 6.45 grams of propane gas at 100 kilopascals and 15 degrees Celsius. This one, someone mentioned what we should use. This is not GCSEs or A-level, it's IB. Isn't this November 2024? It is. That's why I was guessing at which paper to be. Ideal gas equation, good. And which ideal gas equation? We have lots of ideal gas equations. We have the main one, which is PV equals nRT. What is R, guys? N is quite simple because N is our moles. It's always our moles. And so if I'm trying to find the moles, my first step is I'm going to do grams over molar mass. My grams is 6.45. How do I find them? Very good, guys, the gas constant. How do I find the molar mass? Well, I know propane is a 3-carbon pane. So I have 3 carbons and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So carbon is going to be roughly 12. 12 times 3 is going to give me 36. 36 plus 8 is going to give me 44. So I know my molar mass is around 44. I'm not using the decimal places. In your exam, please use the decimal places. 6.45 divided by 44. That gives you roughly 0.15 moles. And again, I'm like rounding up for the sake of simplicity. But if you do these steps, you should be getting the answer correct. So then you have 0.15 moles. You have your gas constant, which is 8.31. Your temperature, can I leave my temperature in Celsius? This is the Chem paper 2, November 2024 paper. Will this go up on YouTube? Yes, it will go up on YouTube, but I'm having trouble uploading them. I don't know why. It's only uploading short versions. I'll try to upload the full one. Sorry, guys, if you try to look at the YouTube videos and they're a bit short. No, you do Kelvin. Perfect. So 15 plus 273 gives me 288. And then, can I leave my pascals and kilopascals like this? Are you going to do bio HL papers? Yes, I did one not yesterday, Tuesday. Exactly, you can leave it at kilopascals. So your volume is 0.15 times 8.31 times 288 times divided by 100, sorry. So let's go ahead and do that on my calculator. Sorry guys, I'm using my phone calculator, so if anyone can do it a bit faster than me in the comments and let me know, that would be very helpful. Okay, and that's the volume is 3.59. And is this going to be in meters cubed or decimeters cubed? What's the units for volume and pressure? Good question. So pressure is in kilopascals and volume is in decimeter cubed. Very good, decimeters cubed. Now, there is options where you can use in meters cubed the volume and use a different type of gas constant, but I don't want to confuse you. Just keep attention to this. Sorry, I'm going to zoom out. Is there a discount code for the Chem Crash course? Of course there is. I'm going to put it in the chat. M2510. I'm going to try to pin it. So if you want to join the crash course, please do. I know some of you guys are still deciding, like, you don't know if you want to join the crash course or not. But I'd really recommend you make your decision before this weekend just so you're able to join it live. Of course, if you want to join it later, just get the recordings, that's okay as well. But try to join it live so you can get the full benefits. Okay, good. Oh yeah, you joined for bio. That's so exciting. And how are you liking bio so far? Please let me know in the comments. Hopefully it's been good. How often are you doing these live videos? I went every day on the weekend, I think, and then Monday and Tuesday, and then yesterday I couldn't because I was traveling. Where did I put the discount code? So I'm not very good with technology, but I think when you pay, like when you get to the final pay, you should have like a discount section and you enter the discount code. It's great. Yay, that's so exciting, Kai. And Kai, if you have any questions about the content, because I know you missed the live session, you can always message the tutor or email the tutor so you can still get the benefits of a tutor. Okay, just ask questions in the chat bot or you have our emails in the resource pack. Okay, what days are you going to do what classes? So the chemistry crash courses start this weekend. They're going to be Saturday, Sunday, and Monday, which is actually not normal. We usually just do the weekends, but since we know you guys have holiday, we also did Monday. And then that will be the whole SL syllabus. So if you're SL, you learn the syllabus in 3 days. But if you're HL, you have to stay an extra 2 days with us. And then it will be the next weekend where we do the HL syllabus. So let me get the dates correctly so I don't bother you guys. But basically, Saturday the 19th, Sunday the 20th, Monday the 21st will be chemistry, SL. And then in continuation, the 26th and the 27th will be HL. So if you're HL, you need the 5 days to learn the whole syllabus. Okay, nice. I'm going to go ahead and move on. It says, outline why the volume occupied by propane at a very high pressure is higher than the value calculated using PV equals nRT. So why is the volume occupied by propane gas at higher pressure, at very high pressures, higher than the value calculated at PV equals nRT? I'm going to give you guys a couple of seconds. Because, someone said the correct answer. Good. Someone name dropped the correct answer. Can you give me more? Because remember, this is 2 marks. So what does it mean that you've mentioned that it's a real gas? Gases deviate from ideal gas behavior at higher temperature. Good. Someone said, do I have to pay for the course in pounds? Good. Very good question. Unfortunately, I don't know, but if you message our chatbot on our website, it will answer because it's our tech guy works in the chatbot. Won't behave like that. Exactly, good. And how does usually an ideal one behave, maybe? So it's not enough just to say that's an ideal gas, or so what is it? What is this behavior? Okay, it's a real gas, so it does not necessarily apply to the gas law equations. Perfect. But can you tell me why the volume will be higher? Exactly. Ideal gases don't have a volume. Perfect, Patrick. Exactly. So you've mentioned first that, of course, it deviates from ideal gases, and that's 1 mark. And then you just have to explain what does it mean that it deviates from ideal gas? And you just say that ideal gases generally have no volume, but this is a real gas, and that's why the volume is greater. Good. Does that make sense? Is this a specimen paper? Hey, no, it's chemistry paper 2 HL November 2024. Exactly, because their volume is no longer negligible. Very good. You still would have gotten the marks. Is that they occupy exactly good. Is it that they occupy? Will you teach all this crash course, or do we have to know it? No, we'll teach everything, really from point zero, from knowing how to convert from Kelvin to acids and bases and redox. Okay. Next it says ethane can be converted to chloroethane by reacting it with chlorine gas in the presence of UV light. State the type of reaction and the name of the mechanism by which it occurs. So tell me the type of reaction, and then tell me the name of the mechanism. And I'll teach you guys a little hack so you're able to know. Okay, so substitution. Very good, Patrick. Good. So people are saying substitution. Perfect. So substitution is the exact type of reaction. And the name of the reaction is free radical substitution, of course. Okay, so you've mentioned that it's a substitution reaction. And that you've mentioned that it's a free radical. Now, how do you know something is substitution? I'll give you a hint. Okay, whenever you have a double bond, like this, whenever you have a double bond, a triple bond, but you don't really see triple bonds in organic chemistry in the IB syllabus, but whenever you have a double bond like this, what ends up happening is that you open up the double bond and you add things. You're opening up the double bond because the double bond is so reactive, it wants to release those extra electrons, and you add things. Okay, so usually if it said ethene or ethene, you know that by like rule of thumb, this should be an addition reaction. But in the question, it asked about an ethane, an alkane. So we know that alkanes, they're already full. There's no space for you to add. All the carbons are satisfied. So by rule of thumb, you always remember that if everything is satisfied, then in order for me to change it from an ethane to a chloroethane, I'm going to be substituting my hydrogen with a halogen. Okay, so a little hint for you guys to always remember, if it has a double bond, it's a substitute, it's an addition, because you're opening that double bond and adding in another bond. But if it's a alkane, so no double bond, only single bonds, then you know it's substitution. Does that help, guys? So, hopefully that helped. Maybe it was a little hack that you guys didn't know about. Is this question SL or HL? This is SL, I believe. Why is it not halogenation? Very good question. It's not halogenation because it's in the presence of UV light, and this is a special free radical substitution mechanism. In the crash course, do you do revision of the topics or practice questions, or how are the classes? So basically, our structure of our slides. Wait, maybe I have a sample slide here. Oh no, I didn't. But I can show you the slides at the end, maybe. But it's basically content and then question. Content, question, content, question, content, question. And so you're learning, but you're also doing practice papers and you're prepping yourself from the beginning. Thank you for the gift. Would SN2 reaction mechanism work? No, it would not. Remember, guys, the hint here is that it's a UV light. And with UV light, your only possible reaction to occur is a free radical substitution according to your syllabus. So whenever you see UV light, scribble down free radical substitution. That's the only ever case you're going to have UV light. Can we ask questions on the crash course if we're on the Zoom call? You can. You can't ask verbally, but you can type in the chat. And we have an assistant tutor in the chat who answers all your questions in live. But you could also ask a question to the main tutor, of course. You can ask her in private, or you can ask in the main chat, whatever you like, because we know some students get a bit embarrassed to ask a question, which is perfectly fine. So you can ask privately, message her privately in the chat, message the assistant tutor privately. You also have access to a tech person who, let's say you're not able to get all the resources, you message tech, hey, I can't find the slides. They send you the slides and so on. So it's really, really fun. And someone asked about the questions in the crash course again. Sorry, guys, but the questions is It's nice because we do like live working out, but we also do this Kahoot style practice questions with multiple choice. So we try to keep it as interactive as possible, but you definitely do end up doing a bunch of practice. Okay, let's move on. It says chloroethane can be converted to ethanol. Identify the reagent and conditions necessary for this reaction to occur. So I'm going from a halogenoalkane to an alcohol. Okay, so try to think. I'm going to draw out my halogenoalkane here. This is my hypothetical chloroethane. Okay, and I want to turn that into an alcohol. So try to think, what can I apply in my solution in order to supply this with an OH group? What is something we know that has an OH group? Very good, Kavya. It's an NO hydroxide ion. So good, exactly. Why do we use sodium hydroxide? Because it's a very strong base. So I must supply my reaction with a hydroxide ion so it can undergo, is it going to be a substitution or an addition reaction, guys? Think about if it's double bonded or single bonded. Someone said, would water work? Yes. In the context outside of IB, yes. In college level work, yes, but not in IB. So make sure you just say hydroxide ion or sodium hydroxide. Very good. You've all mentioned that it's a substitution because it's there's no double bond. There's nothing for me to open up space for my carbon to add a hydroxide group. So I must be substituting my chlorine with a hydroxide ion. Perfect, guys. Okay, so my reagent is sodium hydroxide. You could have also just said a hydroxide ion. You would have gotten the mark. Now, what is the condition? What does this have to be? So is it warm? Does it have to be aqueous? Does it have to be solid? Very good. Wildflower said reflux and warm. Perfect. Good job, guys. I know organic chemistry is really hard to memorize this much content, so you guys are doing very good. Nice. Okay, let's move on to this one. It says butane 1-ene contains sigma and pi bonds. Identify the hybridization of the carbon atoms labeled A and B. And while you guys do that, I'm just going to have a quick read of the comments because I feel like I've missed some things. But this is our B and this is our A. Now, hybridization, I feel like teachers complicate it way too much. But for your syllabus, you don't need to know much about hybridization, which is nice. Okay, perfect. Patrick, you're doing very well. Now I'm going to test Patrick a bit more. And Nat, tell me why it's sp2 and sp3. What is... Very good, Kavya. Nice. So tell me why. Why can we identify that it's sp2, sp3? I'm just testing you guys, so I'm forcing your brains to work. Is this HL question, like this part? Ooh, good question. In the old syllabus, this was definitely HL. I think this is still an HL question. Exactly. I just remember by the number of things. It's bonded 2 minus 1. That's exactly how I remember it as well. Good. This is an HL question. Exactly. 1 less than the bonding. Perfect. It's trigonal planar, so it's sp2. Nice. I also remembers it just by the SPR theory and then subtracting it with 1. Very good. So here I have how many bonds bonded to my B. I have 1, 2, 3, 4. And the way I like to remember is just like Patrick, I do minus 1. So it's because it's bonded to 4, I do sp3. And then here I can see that it's bonded to how many? 1, 2, 3. So I know it's sp2. Good job, guys. Okay. Describe how sigma and pi bonds are formed. Oh, this is a very common question. So make sure you know this. And you have to state 2 keywords in each of those. So if you guys don't state these keywords, I'm gonna be up your bum. Oh, someone said it correctly. Good job, Abby. Good job, Patricia. Oh, we're almost at 4K likes. Thank you guys so much. Our goal was 30K because on Tuesday we hit 30K, which is our new high score, I would say. Good. A bunch of you guys are saying sideways and head on. Okay, so those 2 keywords I was alluding to is head on and sideways. So sigma, if you said, who said it? Who said it? Let me see. Good job, Addy. Exactly. Sigma is head on, overlap. And this one is a sideways overlap. Now, a little trick to show you guys why I like to remember it. It's a bit stupid, but I remember that since sigma starts with an S, it can't be the one that starts with S. So I always remember sigma is the opposite one. But if you guys have a different way, let us know in the chat, because I know it's really helpful also for students to share their little tips on how to remember. So side bond is overlapping above the and below the axis. Okay. Let me see. Oh, yeah, you could mention it above and below the axis. Good job. But for me, I like to always remember head on and sideways, and you still get the marks. But good job. You're going above and beyond. Do you have to mention that it's the p orbitals? Good question. So for the pi ones, because for the sigma, it can. How can the sigma only be pi, or is it also s? The sigma can be both. Exactly. Good job, guys. So you don't have to be really specific for the sigma, because this one it can just happen with both. It can even have a mixture of both. Okay. But here, when we're talking about sideways, it's like this. This is our bonding that's occurring. And can this happen with between sigma? It cannot. So you do have to be specific, but only for the pi one. Okay. I'm going to move on to the next question. Do you have to say more? No, you don't. I mean, usually head on, but in your exam, be extra, be like head on overlap of the orbitals, and make it a full sentence. Do you need to know about the d orbitals? No, good question. All right, I'm going to move on because I feel like most of you got it. Yay, we're at 5K likes. Thank you guys so much. Okay. Butane 1-ene reacts with HBr to produce two structural isomers of bromobutane. Explain which of those two structural isomers is the major product. Ah, someone already answered it. Good. So careful. Someone mentioned the Markovnikov's product. If you just name drop Markovnikov's, you don't get the mark. But let me see. You would have gotten the mark because you talked about the stability. So whenever you think about the major product, the one thing you should always talk about is the stability of your carbocation. What is a carbocation, guys? It's just basically that carbon to hydrogen chain before you've added something to it. So this is your carbocation. And we're talking about C+, exactly. Could I ask a direct message question I had about biology? Yes, of course you can. Do you want to DM me, or I can answer maybe at the end? Okay, so to get the full mark here, you have to talk about the stability. So butane 1-enes, let's first draw butane 1-ene. 1, 2, 3, 4. And it's going to be Br, H. Guys, I jumped ahead, apologies. Let me go like this. So I show you exactly how I got it, so everyone's able to answer it. Okay, this is my butane 1-ene. So what are the two products of this butane 1-ene with HBr? I have 4 carbon chains, like so. Again, 4 carbon chains like so. And then my Br can be attached here, here. Okay, or this is messy, here. Now I'm going to label this option 1, and I'm going to label this option 2. Now vote in the comments which one's more stable, 1 or 2. Someone said I drew it wrong. What did I do? I don't see what I did wrong. Ooh, careful. It's not 2. It's going to be 1. Okay? Because your carbocation, it has 5 double bonds. I don't see what I did wrong, guys. But it's been a long day. 1 is more stable, exactly. So careful, why is 1 more stable? Because your objective is, now you can't explain it like this, but your objective is to have the most stable carbocation. And how do you have that? By having a secondary carbocation versus a primary. Okay? And that's Markovnikov's rule. So because of this carbon is bonded to two carbons, rather than this carbon that's attached to the bromine that's bonded to one thing, this one is more stable. So primary is more stable. No, 1 is more stable. This first one's more stable. The secondary one is more stable. Exactly, perfect, Patrick. So the more carbon it's bonded to, the more stable. I'm just gonna have a quickie. There just has 5 bonds on the second carbon due to the double bond. Ah, sorry. Thank you for clocking me. Exactly, good. Okay. Wait, I don't get that. Okay, no worries. I can explain it again. Do you think the first languages are harder than the new syllabus? No, I think that the chemistry ones will be about the same difficulty because the old chemistry syllabus is the same with the new one. They just move some SL stuff into only HL content. Can you explain again? I can. Please, could you explain again? Of course. Is this specimen paper? No, it's November 2024 HL paper 2. Okay, so the carbocation, remember, is basically when we open up this double bond and we bond the hydrogen here, this is called a carbocation. This carbocation has a really positive charge before we add our negative halogen. So that's what I mean by when I mentioned carbocation, before I add my bromine. Now, the point of saying or getting a more stable carbocation, it's more beneficial for us. So that's actually what's going to be the major product because you want to produce more stable product. Okay? Now, what makes something more stable? If it has more things bonded to it. So, how do I find out if it has more things bonded to it? I look at my product. This is my product 1 and my product 2. So, just like how we would find out if an alcohol is primary, secondary, tertiary, I look at the carbon that's bonded to my bromine, the carbon that's bonded to my bromine, and I count how many carbons are bonded to that carbon that's bonded to my bromine. So here's my green carbon that's bonded to my bromine, and I have 1 and 2. Okay, here I only have 1. And so since this one has more, it's going to be more stable. And it's always the case like that. So it's very easy. Now, how do you explain that in your exam? Well, it's 2 marks. So first you have to state which one is going to be more stable. So you can say 2 bromobutane is more stable. Why? Because the bromine is on the second carbon, not the first. And then to continue, you have to say, that's all you have to say, copy paste this in every single one of these questions. The secondary carbocation is more stable than primary carbocation. I've gotten my first mark here, and then this is my second mark. So this is why I tell you guys to memorize past papers, because the question can be very different, but your answer, that purple that I just wrote, is always going to be the same. So 1 is the secondary. Exactly. Why is it secondary? Because it's bonded to 2 things, 2 carbons. That carbon that's bonded to the bromine, so what's in green, has 1 carbon, 2 carbons, so it's secondary. Do you have to mention, okay, so actually in the mark scheme, it says, do not award a mark for simply stating Markovnikov's rule. So if you mention it, but explain that the secondary carbocation is stronger, more stable, not stronger, than primary carbocation, you'd still get the mark. But if you just name drop this Markovnikov's rule, you would not get the mark. So be very careful. Okay, now someone talked about the inductive effect. You can talk about it in terms of the inductive effect, but I think this is a much easier way to say it. But if you want, you can also talk about it. It's not a requirement. Is it that the more carbons there is bonded to, the more stable? Exactly, good. Is this HL or SL? This is HL. What was it about primary and secondary? What do you mean? What was it? Like, how do I know something is primary, secondary? Does it have anything to do with the type of chemical bond? No, it's just about whether it's straight chained or like branched, and that affects the stability. Oh, how do I find primary and secondary? Okay, so this is a secondary one. Just like you would do with alcohol, guys. How do I know that this is a primary alcohol or tertiary alcohol or primary amine? Actually, that's a bit different, but an alcohol. It's the same thing here with the halogen alkane. You have your carbon that's bonded to your bromine. Your carbon that's bonded to your bromine. You're going to focus on this. And to that carbon, how much things are attached to it? 1 and 2. So 1 carbon is attached to it, 2 carbons attached to it. This here is just a hydrogen bond, so we don't have to worry about that. We're only focusing about the carbon. Now here, this one, okay, it's only bonded to 1 carbon on this side. On the other side, it's bonded to hydrogen. So we know that this is secondary, this is primary, and this is more stable. Did that make sense, everyone? Please tell me if that helped you or if you want me to re-explain, I'm happy to re-explain. This is HL, guys. You do the lives on YouTube. I don't, but I try to upload these on YouTube. Lately, I've been failing to upload them. I don't know what's wrong. Like when I'm downloading, there's an issue, and it only ends up posting like 30 minutes of the live, which is annoying. Yay! Okay, good. I'm happy. So, okay, take a screenshot. Stop and take a screenshot of the purple, so that you memorize this. And whenever a question gets like showed up on the exam, you know exactly this is what you have to say every single time. Okay, I'm gonna move on. And thank you guys for 7K likes. Okay, we're gonna do this question. And explain the mechanism for the formation of the major product using curly arrows to represent the electron pairs. So not only did you have to find the major product before, can you zoom out a bit? Of course. The major product before, but you have to draw the correct one here, so you have to be very careful. I've noticed that all the exams there's acid, base, and electrode stuff. Would you agree? I would agree, 100%. I really like our electrode crash course slides. What paper is this? This is the 2024 November HL chemistry paper. And sorry guys, I think my discount code. Can you guys still see the discount code? It keeps going away. I think when I pin stuff, it doesn't stay. Someone please help me and write M2510 in all caps so I can pin it. Maybe it'll stay longer. My worst two topics. Yes, they were mine as well. I hate it. Can you do certain topics like electrode crash course only? Well, you can buy. Okay, thank you. Thank you, Kai. I pinned it. Yay. Okay. So can you do certain topics? So you can buy day passes of the crash course. Let's say you only want to do the HL topic of acids and bases and you don't want to waste your whole time doing the whole crash course. Valid. I mean, everyone has their own preferences. You can just buy the day of the acids and bases. Okay, I'm going to go ahead and answer this. Thanks, Benny. Okay, perfect. I'm going to go ahead and answer this, and I'm going to be specific about what the IB needs you, because they're actually very specific about our organic drawing. And I remember our main tutor, she spent so much time, our co-lead tutor, she spent so much time making these slides, so you know how to get every single mark. So pay attention with this, because the IB is very picky. Yeah, it's just drawing, so hopefully it's not too hard to memorize. But the first thing I'm going to do is I'm going to draw my molecule. So my butane has 1, 2, 3, 4, 5. Hopefully I didn't make any mistakes. Yeah. Okay, so this is my butane 1-ene. And I know that it's HBr. Okay, so if this is a really, really negative... Okay, first I'm going to ask you guys, what is negative and what is positive? Is my hydrogen negative or is my hydrogen positive in this HBr? I can zoom out, sorry. Which one's more negative? Hydrogen is positive, good. So I know that this is positive. You don't have to say it to get the mark, but I want you to work with me so you remember things easier. Very good, guys. And my bromine is negative. Good, exactly. So if I tell you that there's a double bond, and we know double bonds share a lot of electrons, can I ask you, is my double bond going to be negative or positive? This is HL Chemistry IB. It's November 2024. So is the double bond going to be very good, guys? There's lots of electrons, so it's going to be negative. So I'm just writing this here so it can help you visualize. Now, what do you actually need to write to get the mark? You need to draw your butane 1-ene. You need to draw your HBr. I'm going to do the things in red. So my negative gets attracted to my positive hydrogen because we know they just attract. Okay? So then what ends up happening is that it wants to give its electrons to hydrogen. So hydrogen's like, all right, I'm going to take your electrons because you're much more reactive, and vomits out, well, just gives out, pushes away its electrons to bromine. So now bromine has extra electrons. So that's the first step. And then you draw your arrow, and you have your just like this. And I know, because we talked about which one would be more stable, if I drew this, guys, what would be wrong with this? I'm going to test you. What would be wrong with me drawing this? This is not a specimen paper. It's not the major product. Exactly. I can see that. I can kind of predict in the future that when I add my bromine here, it's going to be a primary carbocation. This is a primary carbocation. Exactly. Good job, guys. So it's not the most stable. And here they've asked me to draw the major product. So I'm already going to erase this out. I know this is wrong. And I know my hydrogen's going to bond here. And this is going to be the positive carbocation. Now, this is positive now. And my bromine, just like we said, is going to be negative. Br minus, because Br is always negative, and now hydrogen gave it those extra electrons that I didn't want to use. Okay, so then of course what's going to happen, my bromine, my negative, is going to be attracted to the positive. The arrows always go from negative to positive, so that's a little hint to help you draw. And then all you have to do is your final thing, which is draw your halogen alkane. Did that make sense, everyone? So we do not have to draw carbocation, no intermediate product. No, you have to draw exactly this. I'm sorry, I forgot. You're supposed to draw like a black arrow between this and this. Draw this a bit small on your exam so you have space. How do you know it's not the major? How do we know it's not the major product? So I explained this a bit earlier. Halogens always be on the secondary carbocation. Yes, if they mention the major product, because we know secondary carbocation is more stable. So if you were here earlier in the live and you understood what I explained, try to answer, try to rephrase what I've mentioned before, what I've highlighted in purple, and try to help people out. Okay? It'll help you also. Teaching people is also very helpful in learning. Don't you have to draw the arrow from the negative to the bromine? You should draw from these electrons, these lone pair of electrons. If you were there during my first semester, how I think about it is that the hydrogen will prefer to go to the carbon with more hydrogens. Oh, cute. Yeah. Isn't this just more carbon copies? Exactly. You can also represent the lone pair as 2 electrons. Exactly, so the halogen will always bond to the most stable carbocation because here specifically asking you for the major product, and they'll usually ask you for the major product. Okay, I'm gonna move on. I feel like you guys are helping out and answering, which is very kind of you guys. And we're almost at 8K likes. Thank you guys so much. Our like goal was 30K. I don't know if we're gonna reach it this live, but hopefully we do. Someone asked, is it always gonna be the second carbon then? I would say with 90% certainty, let's say you don't know in your exam, just draw it on the second one, because that's always going to be the stable one, is going to be the secondary carbocation. And I don't want to tell you, like, they're always going to ask this in case there's 1% chance they don't, but in the past, they've always asked this, okay? I'm going to move on. Someone said tertiary is more stable than secondary. Exactly. So if there was a tertiary one, you would be drawing the tertiary one. So always put the bromine on the highest level of bonds. Okay, I'm going to move on to this one. It says, one of the structural isomers can exist as a pair of enantiomers. State the name of an instrument which can be distinguished between the enantiomers. This is a really good one to get them more because it's just naming an instrument. This is not a specimen paper. This is a HL November 2024 chemistry polarimeter. Good job, guys. And I love state questions because you don't even have to write in a sentence form. Oh, okay, moving on. It says potassium and potassium chloride both form lattice structures in the solid state. Predict with reason the electroconductivity of Ks and KClS. So is Ks going to be, can I have electrical conductivity? What about the solid form of this? This is your worst enemy? Yeah, this was my worst enemy too in IB. This was horrendous. Like, Can you please zoom out? Of course. Sorry, guys. I have to keep zooming in so I can write things down. Good. Why will K have high electric conductivity? Perfect. Yusuf answered it. Nice. Okay. Good that you guys have mentioned the bonding. Because with electric conductivity, you're always talking about the bondings, the intramolecular forces. You're talking about the electron movement delocalized. Perfect. Metallic bonding. Okay, good. So it's not enough to just say metallic bonding. Whenever you're talking about electroconductivity, you're trying to talk about free floating charges. So whether that's in the form of delocalized electrons, whether that's the form in ions, but you always have to mention those two things in connection with electroconductivity. The first one you say it's a metal, it has metallic bonding. Therefore, it will have high electrical conductivity. Because of the delocalized electrons. Okay? Now I'm going to highlight in red exactly what's supposed to be on the mark scheme. So high electroconductivity, delocalized electrons. Those are the two key things that they're looking for in the mark scheme. But of course, you're going to add a bit of fluff in your answer. So it makes sense. Good caveat. So someone already moved on to answer. So tell me KCl as a solid. What is that type of bonding? It's ionic bonding. Okay. Ionic bonding can have electroconductivity, but in a special case. That's when we have free floating ions. Remember, I talked about how electrical conductivity in terms of your syllabus is only in connection with this free floating charge, whether it's in the form of delocalized electrons or in these cations and these anions. Now here, since we have a solid, they're not free floating. So I would say not good electroconductivity because it's solid. Therefore, ions are in fixed lattice position. Now, just say position. You don't have to be extra and say lattice, but we know ionic bonds have a lattice structure. Good job. So KC will only conduct electricity as molten or as what? There's molten and there's another one. Someone says it. Lillian says it. Said it. Exactly. Very good. As aqueous solution or as molten. Perfect, guys. We're going to move on to this one. And I'm going to tell you how to answer these all the time correctly. So don't worry if you guys are a bit scared about this one. But it says the electrolytic cells are connected in series. All electrodes are inert. State the half equation for the reaction occurring at each electrode in cell 2. Use section 24 of the data booklet. So here I have my Cu copper sulfate and my KCl minus. Now, the first thing I'm going to ask you is, oh no, it already tells in the answer, but I'm gonna go up to make you guys do some active recall. Is this one my anode or my cathode, or is this one my anode or cathode? In the question, you don't need to know because they give it to you. Yay, we're almost at 10K likes. Thank you guys so much. Oh, Yusuf's onto something, but why? Tell me why, Yusuf. So the positive is the anode. Good. Exactly. It says in the answer. So this is the positive, the anode, and this is the cathode. And in the anode, what always happens? Is it out of redox? Is it always oxidation or is it always reduction? Good, Patrick. Oxidation. Always in the anode, it's oxidation. And in my negative, it's going to be reduction. Always, always. Voltaic, electrolytic, any type of cell, it's always. Aurora said red cat. So remember, red is cathode. Good. Red cat. And ox or red cat. Okay, good. So here I have my anode and my cathode. So here I know whatever's going to happen is going to go oxidation. It's going to oxidize, and here it's going to reduce. Now, what you have to be careful of when you're looking at this. So usually in electrolysis, you only have to focus on your metal and your ion, like your ions here specifically in the solution. But since it says, what does it say? It says aqueous, I know that this is dissolved in water. So not only do I have to think about the K plus ions, not only do I have to think about the Cl minus ions, I have to think about other ions that are in my solution. What are those ions? I know water can be broken down into an H plus ion and an OH minus ion. So not only do I have to think about my K plus and Cl minus, I have to think about my OH minus and my H plus. So this complicates things. Be careful not to make that silly mistake, because a lot of students will get this wrong because they'll not even notice that it's aqueous. It doesn't tell you that it's aqueous. They want you to read the question. Okay. So, okay, so at our anode, I'm going to make you guys do more active recall. What can be released? Is it my hydrogen gas or the gas, or is it my oxygen? Because we know that there's two things. At my anode, there's always what? Oxygen gas, perfect. So remember, anode, oxidation, oxygen gas. So this is always oxygen gas. Now, what does it depend on? If my reaction is concentrated, you release the halogen gas. So if this was a concentrated solution, you would release chlorine 2 gas. But since it very clearly says dilute, you always write oxygen gas released. So you're going to need to state the half equations, but for now, I'm just going to write oxygen gas released. And then we're going to go to the data booklet and find those half equations. Does this make sense, everyone? So anode in electrolysis is positive. It always undergoes oxidation in both electrolysis and voltaic cell. And what's special about it is that if it's dilute, it always releases O2 gas. If it's concentrated, it always releases the halogen. Why is oxygen gas released? It's always oxygen gas in the anode. You have to remember this. Because your OH minus is what? Your OH minus is negative. So the negative is attracted to the positive anode. That's why your oxygen is always released. But that's only when they say dilute. When the concentration is concentrated, it's always going to be your chlorine gas. So let's say this was not an aqueous solution, or let's say it was an aqueous solution and they told you concentrated. That means your Cl minus, your negative Cl minus will be the one that's attracted. But when the solution is not concentrated, you always have oxygen. So what are you looking for? You're looking for to make sure to identify this as aqueous. And if it says dilute, run and write your answer as oxygen in anode. Always the case. 100% of the chances, okay? If it said concentrated KCl, then you have to be careful. It would be the halogen, so Cl2. Does that make sense, everyone? So have we got our anode down? Please let me know in the chat. If not, I can explain again. Don't worry. We're almost at 10K likes. Thank you guys so much. My discount code for the crash course is left. I don't think TikTok likes me very much. How is the halogen CO2? No, the halogen is Cl minus. Did I write CO2? So concentrated just means that there's like a lot of the halogen. If there's not enough halogen, the oxygen will get the priority. So dilute means that there's not enough of your halogen. There's not enough of your potassium and your halogen. So by automatic, it will produce O2. But when it's concentrated, there's enough halogens to form the gas, and therefore the halogen will always be formed. Okay, guys? Does that make sense? Please let me know. If it's dilute, we have to check what's oxidized or always water. Good question. So if it's dilute and it's aqueous, then you 100% know it's going to be oxygen. If it doesn't say anything about it being aqueous, then of course it's going to be your halogen because there's not even an OH group for your oxygen to be released. If it's aqueous and it's dilute, it's always oxygen. If it's aqueous and it's concentrated, it is always the halogen. Now it's not aqueous, of course you don't have oxygen, so it has to be the halogen. Does that make sense, everyone? Is this biology? No, it's chemistry. So if concentrated halogens and dilute oxygen. Perfect, exactly, that's all you have to worry about. The discount code is not working. Oh no. Try again. Someone said also as well, they messaged me on the DM, they said it was not working and they said refreshing helped. Tell me if it helps when you refresh. If not, I'll message tech right now because that's so sad. Will it always say dilute or concentrated? Yes. But yeah, it will always say. This doesn't make sense to me. Okay. Does this not make sense to anyone else? Because if it doesn't, I'm going to draw you a table, and that's okay. Let me know if that does not make sense. Me too. Would you guys? Okay. Put yes in the chat if you want a table. You don't get it? Okay. I'm going to draw a table. So, your anode. This is your anode. And take a screenshot of this, okay? So you remember when you're studying. If you don't get this, memorize this, okay? Don't worry. Or if you don't get this, join our crash courses. We explain it even better. Are you in uni? I am, okay? So your anode in your electrolysis is always positive. Let's mention that first. Okay, so out of your Cl minus, your OH minus, your potassium plus, and your H plus, of course I know the negative is going to be attracted to my anode. So halas, I can cross this out and this out. We don't have to worry about this or this. Okay, so Cl minus and OH minus, that's already given. Now, if the solution says dilute, you always say O2 is released. Okay, you always focus on the OH minus ion becoming O2. If it says concentrated, then it's always the halogen. So in this case, it's always Cl2. And I'm going to write halogen in brackets, and it's usually always a halogen. So your anode is positive. If it's dilute, it releases O2. If it's concentrated, it releases Cl2. Now, this is the case when what? When we have aqueous. Why is that only in aqueous cases? Well, because when your solution is not aqueous, what does aqueous mean, guys, first of all? Aqueous just means we have our ionic compound, dissolved in water. Okay? So when something says aqueous, that means they're always saying that there's hidden H plus and OH minus ions hidden in your solution. But if this did not say aqueous, and it said liquid, that means the only ions I have here are potassium and Cl minus. So your question gets much easier because you don't even have an OH to worry about. You don't even have, so without the memorization, why is that the case? Because if it's dilute, you don't have enough of the Cl2 to, okay, guys, if you have Cl minus like this, you need 2 of those to make Cl2. If there's not enough chlorine, if it's diluted, that means there's more water than there is chlorine. So it's just easier for you to create the oxygen. Okay? You never have to explain it in your exam. This is way beyond. They're never going to ask you, explain why oxygen is released. And if they do, you just say dilute, concentrate, it's dilute. Okay? But they never do that. They just ask you in this difficult format. Thank you for the rose, guys. What's going to be there? Okay, does that make sense? Hi, SP. Please let me know if that makes sense. Okay, so aqueous, this is always what you're going to have. Have this as a cheat sheet, and you're always going to get the answer correct. Now I'm going to move on to cathode, because cathode is horrendous. Okay, I'm going to move on to cathode. Did everyone screenshot? Thank you guys for 11K. Okay, screenshotted? Yes? Good. Now I'm going to move on to cathode. So we're cathode. What did we say about cathode? Cathode, we said, it's negative. That's the first thing we have to remember in electrolysis. Now, what are the 2 things that can be released in your cathode? If it's negative, it's attracted, of course, to the positive things. So it's going to be H plus or your metal, because your metal is always going to be the thing that's positive. So H plus or your metal, in this case, it's potassium. It could have been magnesium, it could have been whatever. So if it's your potassium and H plus, you have to find out which one's actually released. And this is how you do it. If your metal is less reactive than hydrogen, it is released. Otherwise, H is always released. How do you know that? In the old syllabus, they were very mean because you didn't get the data booklet in the paper 1, but now you get it in all. So I'm going to show you how to do it. You're going to go to your data booklet. I used to memorize a little mnemonic to help me remember which one's more strong. You're going to go in your data booklet. Okay. And I know my H2 is where my H2 gas is here. Why? Because I'm producing H2 gas. That's an ugly color. But that's my H2 gas. So I know if it's above it, or maybe this is actually better. No, where's our reactivity table? Okay, there you go. This is our hydrogen. So everything here is more reactive. Everything here is less reactive than hydrogen. Okay, so all you have to do, if it's in the if it's in the cathode, is just to see if it's above hydrogen. If it's above hydrogen, then hydrogen is being released. If it's below, then it's the metal. Okay? So I'm going to test your guys' listening skills, and I'm going to ask you, if it was hydrogen and copper, which one would be released? Have a look at the data booklet. I know you guys have a new syllabus data booklet. Okay, no worries. If you don't get the reactivity table in the data booklet, have a look here. You can also memorize it, but we can take a look here. If it's above it, it's released. H2. If it's below it, released metal. Doesn't matter, it's the same thing. Okay, so if hydrogen and copper, which one's released? If it's less reactive, the metal's released. Which one's released? Very good, Patrick. So what do I mean release metal? So in your cathode, you can either release the metal or you can release the hydrogen. If it's less reactive, so below it on this table, it's less reactive. And therefore, my metal is going to be released. If it's more reactive, so above it, my hydrogen is going to be released. Okay, so copper and hydrogen, which one would be released? Someone said it correctly. Copper, exactly. Okay, now what about, I'm going to give you another one to test you guys. Magnesium and H+, which one would be released? Good, exactly. Someone said, what is the logic behind that? The more reactive one is released. H2, perfect. No, not the more reactive one. The less reactive one is released. Because it just requires less energy. Can I zoom out? Of course. So hydrogen is less reactive than magnesium. It requires less energy, and therefore hydrogen is going to be released. Now, what about silver? Which one's going to be released, guys? But the higher one in the data booklet, exactly. Higher one in the data booklet is going to be released. But in terms of the concept, it's the less reactive one is going to be released because it doesn't require as much energy. AG, very good, guys. Does that make much more sense? Hopefully that does. So now going back to this question, I have my potassium and I have my hydrogen. Which one's going to be released, guys? M25, then discount code. Discount code. Go on. Hydrogen, good. Do you see how easy it was to answer that? And you never have to explain why hydrogen's released. You never have to explain why this is released. Most of the questions are just difficult enough to ask you which one's released. So good, guys, it's hydrogen gas. Now, of course, you can't just write hydrogen gas because here it says state the half equations, but it's pretty simple. You go in your data book and you find the half equations. What is the half equation for hydrogen gas? Here's your half equation for hydrogen gas. Why? Because I know I'm releasing hydrogen. So I have my H2 L here. Plus my electron to form my 1/2 H2 gas plus my OH minus. Okay, you just formed your H2 gas. And actually, if you don't even mention the OH minus, you still get the mark. But I just like copying exactly what's in the data booklet so I don't make a mistake. All right. Now, how do I find the oxygen one? I just look in my data booklet and see where the oxygen is produced. Here, do you guys see this one where I have O2 gas being produced? Okay, so I'm going to copy this one. Someone said, why not the other H2 gas equation below? You can also put that one. You get the mark for both of them. It doesn't matter. You just have to show a half equation where H2 gas is being produced. Good question, though. Okay, I'm going to do this one. But what do I have to be careful? This shows the reduction. Why? Because I'm adding electrons. So I have to just flip this one, flip this equation, but copy it exactly as it is, but flip it so I'm showing the examiner that I understand that at the anode, oxidation occurs. That's why I had you guys name drop that in the beginning. So how do I write this one? I just write the other way. So H2, L, 1/2, O2 plus 2H plus 2 electrons. Okay? Does that make sense, everyone? Do you guys think you could answer this one by yourself if I gave you a practice one? Let me know in the chat. Hopefully it makes sense. Yay! Okay, that makes me so happy. Maybe we'll do another one so you guys can understand. Of course. Okay, rate your understanding of this in the comments out of 10. Wait, so we flip it around to make it an oxidation reaction? Perfect, because you have to remember anode is always oxidation and cathode is reduction. So you have to be able to illustrate that in your half equations. Everything here in your data booklet is reduction. So whenever you're talking about everything here, because all the electrons are on the left-hand side, I always like to remember oxidation on the right, left hand is my reduction. And everything here is drawn in redox form. So whenever they're asking you about oxidation, always flip the question in this case. Okay, someone said, I'm scared I will forget about water. Don't forget about water. It's only in aqueous. That is the most common error to occur, but check. If it is aqueous or not, you will never forget. Maybe you guys want to screenshot this. Tell me if I'm too zoomed in because I can't really know. But screenshot this bottom part about the anode and the cathode and have it as a cheat sheet. Is it different with voltaic cells? Yes, it is. Because of course you have a different positive and you have a different negative. With molten, it's much easier because in molten, you don't even have the OH minus and the H plus. So all you have to say is that the metal is released in the cathode because your metal is positive, so it's attracted to the negative cathode, and then your halogen is released at the anode because it's attracted to the positive anode. Okay? All right, I'm going to move on, guys. Thank you guys so much for 13K likes. We're almost at our like goal, 35K. And every single time I pin the crash course code, it always goes away, pissing me off. I don't know what I'm doing wrong. Pin. Okay. Of course, no worries. Bye, Patrick. All right, I'm going to move on. Identify the product of anode in cell 1. So in cell 1, what is going to be the product in the anode? We've already done that. What is the product? Oxygen. Good, guys. Determine the mole ratio of non-ionic products formed at the cathode, which is the negative electrode, in cell 1 and cell 2. So what is the mole ratio? Now, whenever you're thinking about redox, whenever you're thinking about mole ratio, what are we focusing on, guys? What is the thing? Good, Yusuf put the right answer. But tell me, how did you get that one? Whenever you think about mole ratio in electrons, what are you thinking? Oh, I gave the answer. Sorry, guys, it's been a hard day. But long day, not a hard day, but whenever you're thinking mole ratio in redox, you're always thinking about the ratio of electrons. Always. So think mole ratio. Redox question, so I'm just going to count the ratio in difference of electrons. So here, in the cell 1 at the cathode, I'm releasing copper. And here I'm releasing what? Oh no, sorry. In both of them I'm releasing hydrogen. And here I'm releasing hydrogen. Okay? So I know that it's a 1-to-1 ratio. Because for every single one, you have 1 electron. Thank you for the gift. Thank you so much. This is Chem. Hi, V. All right. I'm going to scroll down, but it is a 1-to-1 ratio. Perfect. Next, it says to state the number of each type of subatomic particle in potassium ion. This is a pretty easy question. Why didn't you flip the equation for the anode? I did flip it. Should have flipped it. So for this one, what are we looking at? We have the atomic mass, which gives us what? The weight of the neutrons and the protons. Good. And then we have the protons should be the same as our electrons, but since it's +1, I'm subtracting 1. So here I have 41 minus 19 to give me the protons. Oh, sorry, no. 41 minus 19 to give me the neutrons, which is going to be 22. My protons is going to be the exact atomic number, which is 19. And then I have 19 electrons, but since I have an ion, I'm subtracting 1 to be 18. Okay, hopefully this was a straightforward one, guys. I'm going to move on, but let me know if you want me to re-explain that. Outline the evidence that the electrons in potassium atom occupy 4 main energy levels. So what is the evidence that the potassium ion, and this one will be helpful to look at the data booklet. Okay? Can you explain the ratio again, please? Of course I can. In the previous question. Oh, zoom out, please, in the book question. This is HL, but this is, if you're SL, you should be able to solve this. Yay, we're at 14K likes. Thank you guys so much. So what is the evidence that we know that they occupy 4 main energy levels? Can anyone tell me in the chat? So we can have a look at the periodic table. Give you a hint. Good. Someone mentioned the successive ionization energies. Good. Exactly, it's in period 4, so I know that it occupies exactly 4 energy levels. But the key thing with this one is that they're asking you, what is the evidence? Outline the evidence. And Kavya name dropped it perfectly in the comments, talking about the successive ionization energy. So when we're looking at the ionization energies, it's the successive ionization energies, which is just basically a diagram to show how much energy it costs, how much energy it requires to remove an electron. And as you go from those major energy levels, of course, there's a dip. There's a huge increase in how much energy you need. So successive, by looking at the successive ionization energy, that's 1 mark, we can see major differences of energy required to remove electrons when jumping between energy levels, okay, helping us see that there is 4. And one thing that's nice is that they actually explained, they allowed you in the mark scheme to draw the graph. If you want to draw the graph, you can as well. And you would have gotten 2 marks if you just drew the graph. So there's 3 big jumps in successive ionization energy, and that helps us see that it's 4 main levels. So successive ionization energy, remember ionization energy is the amount of energy required to remove 1 electron. So successive ionization energy is just you continuing to remove more and more electrons. So if I draw the graph, and this is energy, and this is number of electrons, whatever. Here, the first one's going to be hard to remove. But the second one, let me scroll down. Second one's going to be harder to remove. Actually, let me look at this one. Since potassium only has 1 electron here, it's going to be really hard to remove the first one, of course. But the second one's going to be even harder to remove. Someone said, why can't you just say it's in the 4th period? Because you have to explain, outline, and evidence. What evidence can scientists use to help prove this? Do you do bio? Yes, we do. And we even have crash courses. I put a discount code in the comments so you guys can use it. But our crash courses are both bio and chemistry, and we teach you the whole syllabus in 5 days. If you're SL, it's only 3 days, but if you're HL, it's the whole 5 days. You could also just buy an HL pass, which is the last 2 days. Because let's say you're, the the SL content really well, and you just want the HL content. We also provide those 2 days. as an HL pass. But I would recommend to like do the full thing, because sometimes it's still really helpful to get the insights from someone who's analyzed past papers about what you guys should do, what you guys should focus on. So I put the discount code in the chat. Okay. So careful with this one. Says why not just fourth period, because you must say evidence. Now, the successive ionization energies, then you would see this big jump in energy because you're going from the fourth period to the third period. So of course, that's closer to the nucleus and therefore would require much more energy. And then you would draw 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on. And you would draw, and every single time you go from one period to another, it would of course show a higher and higher dip. Okay? Someone said bio is mainly memorization. How do you finish in 3 days without memorizing? So one thing that really helps with memorization is the way you're taught things. And sometimes students just memorize things without even understanding it. And so it's really, really helpful having someone explain these things to you, what you need to memorize, how you need to memorize it, in like verbally out loud while you're taking notes, because then it helps you already memorize a lot of stuff and it helps you understand the syllabus more, so you're not wasting your time memorizing useless stuff. Okay, I'm going to move on to this question because I think the anode one took us quite long, and I think I'm going to end on this question because I do have to go. Apologies, guys. Tomorrow we can continue with this exact past paper and continue these, okay? Because I think the anode and the cathode one took us quite a bit of time, but that's okay. So the more energy levels, the higher the ionization energy. Ooh, careful how you phrase that. So, no, because the more energy levels, the further you are away from the nucleus. So the easier it is to remove that electron. Okay? What we're just showing here is that when you have successive ionization energy, you're going to be removing the electrons, but it's going to be harder to remove the electrons from the periods closer to the energy levels closer to the nucleus. What time will you be live tomorrow? Around the same time, so around 6:30 CST. Okay, I'm going to continue this one, and then we're going to finish off today. It says potassium reacts with water to produce potassium hydroxide. And here's our nice equation. I always love when they give me an equation because I don't want to draw my own equation. But it says calculate the enthalpy of the reaction in kilojoule per mole when 1 mole of potassium reacts with water. Use section 12 of the data booklet, and it gives you the formation of potassium hydroxide here. So this is negative 481.8, and it tells you it's the formation. So what do we have to do? We have to do products minus reactions. Okay, what's going to be the enthalpy of formation of H2, guys? What about calcium? Not calcium, potassium. Can anyone tell me, what do elements? What's their enthalpy? 0, very good. 0 for H2, and what about potassium? 0, good, guys. So all I'm going to be looking for is water. Now, what do you have to be careful of? In your data booklet, you have to make sure that you're looking for the L, the liquid one, because the question asked for liquid. So my enthalpy of formation is negative 285.8. I'm going to write that down. Negative 285.8. And that's my H2O. My H2O is my reactants. This is my product. I know for formation, I just have to do products minus reactants. So I have negative 481.8 times the coefficient. You cannot never forget the coefficient. Minus the reactants. Also times the coefficient. And you have your answer. Because we know, why is it 0? Why is H2 and K? Because they're elements. So enthalpy of formations can only be calculated in compounds. Okay? If someone wants me, oh, my light died. If someone wants me to explain this in terms of the Hess's law triangle, I can as well. So just let me know in the chat if you want me to do that. I'll try to do it as quickly as possible before we end the live. I'm not sure how to plug this in. Yes, okay, I can go ahead and do that. course. I would really recommend you guys learn this product minus reactants because it saves a lot of time. But for Hess's Lost Triangle, don't worry. In the old syllabus, they actually preferred you to do the Hess's Lost Triangle more. So whenever you do products minus reactants, you don't really have to worry about the signs. The signs stay the same. Oh yeah, sorry. This is supposed to be negative. Apologies. That was just an error mistake on my end, like a rewriting mistake. Okay, let me show you Hess's Lost Triangle. So you have your 2ks. Oops. I'm tweaking, guys. 2ks plus 2h2l to 2ko aqueous, 2h2 gas. Okay. We know that in your Hess's Law triangle, you have your equation and you have your elements at the bottom. What does that mean? So basically, everything you write here is going to be your elements that form this. Your elements that come together and form this. What does that mean? So here you would usually write your potassium plus your oxygen, your H2O, whatever you want to write. All of these elements come together to form potassium hydroxide. The point I'm trying to tell you is IB doesn't care. This is way beyond your syllabus. So what can you just do? You can just say, this is my secret squiggle circle that has all the elements. It's a plot of all the elements I need. Now, what do I just have to worry about? I just have to worry about filling these diagrams. So what elements do I need to make potassium and hydrogen? They, first of all, have zero formation values. So I can just put these as 0, 0. Now, what about my potassium hydroxide? To form potassium hydroxide, they've told me that it's the elements added together form negative 481.8. Okay? Next, whatever, all my elements here, doesn't really matter, form H2O. So they are negative 288, 5.8. Okay? So this is my Hess's Lost Triangle. And how do I find the enthalpy of formation of this reactor? So what I've highlighted in yellow, I know that the route to my reaction does not change my outcome. So I can go this long route here, and it would still give me the same as from H2 to potassium hydroxide. Someone said, why zero formation? That's just the way it is. Elements do not have enthalpy of formations. So when you're forming a compound, you have an enthalpy of formation because it has to be a compound. Okay, so how do I get from this to this? Actually, let me do it the other way because I'm starting at my H2O and going to my potassium. It's the same thing. So I have my H2O, and since I'm going against my arrow that I've drawn, because before it was forming, so I'm going from my secret plot of elements to my H2O, I'm going to go against my arrow. So if I'm going against my arrows, I always change the sign. So I add a negative. So negative 285.8. What do I have to be careful of? To multiply this by 2, because it says 2 waters, and the enthalpy of formation values in the data book are always to 1 molar ratio. We have to make sure to apply V for the molar ratios, which is 2 here. And then I'm going to continue, follow my arrow, and end up here. And since this arrow is in the direction I'm heading, I don't have to worry about changing the sign. So I just go minus 481.8. What do I have to do? Multiply this by 2. Because I have to apply the ratios. Okay? So if you prefer it this way, you can do it this way. I think it just takes a bit longer than the products minus reactants, but whatever you prefer. I'm going to zoom out in case you guys want to screenshot both of these methods. They both work and they both give you the same answer, which is nice. Does this make sense, everyone? Please let me know if that makes sense. I'm going to put the discount code again because I know it left. Yay! Okay, good. Okay, let's have a look at the last 2 questions before we end the live. It says, describe the difference between the reactions of sodium and potassium with water. This is a good one to get. Someone said, I have a question. Tell me. Okay, so look at your data booklet, and you have to look at your group. Is potassium lower or higher? It's lower, right? And we know reactivity increases as you go down this group, as you go down this alkali metal group. So I know potassium is going to be more reactive. So someone said, what is the condition when it's product minus reactant? What is the condition when it's reactant minus product? So when they give you the formation, do you see that little F here? When they give you the delta H of F, it's always product minus reactants. When they give you the delta H of combustion, it's always reactants minus product, always. All right. So going back to this one, very good, guys. You did mention that sodium will be less vigorous. And when it's telling you to describe, they want you to describe what you're seeing exactly. So you can't just say potassium is more reactive than water. Potassium is more reactive than sodium. You have to explain, describe the difference. So you can say sodium will be less vigorous, will produce less bubbles. Anything that you would visually see, and it could also be slower. Anything like that. Demonstrate with an equation the acid-base nature of K2O. So whenever you have a question that says show us the acid-base nature, what do I have to react my salt with? Can anyone tell me? Very good, Kiwi. Potassium is more reactive than sodium. Make sure you describe it a bit more to be able to get the full marks. Water, nice, Kiwi, exactly. So you put it with water, H2O. Okay, and your H2O. Make sure you mention the state symbols. Okay, then you have the formation of what? You have your formation of your potassium ions. Because remember, we said when a salt is mixed with water, it forms aqueous solutions. And then you form your hydroxide ions, a bunch of hydroxide ions. So we know, what does potassium hydroxide oxide form? It forms OH, and that's how we see that it's a base. We know all of our metals. Let me give you guys a little hint before I go. All of our metals here are going to form bases. All of our halogens are, mostly are halogens. Whenever you have HCl, HF, you'll never see HF because it's way too strong of an acid. HBr, those are all really strong acids. And these are all really strong bases. So when you think of a strong base, always remember the alkali metals in group 1 and group 2. Think of strong acids, you're going to think of the halogens. You're also going to think of these three, H2SO4, HNO4, NO3, and H2NO4, I think. Hopefully I wrote that correct. No, I didn't. HNO4, H2SO4. Something is wrong with this. I can't tell what it is. H2O4. Okay, but remember that all your metals form bases, and that's why we've created a hydroxide ion. And then your halogens and H2SO4, HNO. There you go, HNO2. There you go. That was what's wrong. Thank you. HNO2 and H2NO3. Thank you so much. Okay. Do you always have to balance when they ask you for a question? Yes, you always have to balance. You always have to put the state symbols. So state symbols and balance, or else you won't get that mark. And it's sad if you know the equation, but you don't say the state symbols or you put the marks, then you won't get the marks. So, sorry, don't put the coefficients and the state symbols so you won't get the marks. Of course, I can zoom out here. Okay, is this Chem HL or SL? This is an HL paper, but if you're SL, you should be able to do this one as well. Is there this for ESS? Unfortunately not, but next year we're planning on